Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, this is the episode that I'm really excited about. This is when we power up this amp for the first time and it sort of comes to life. We're going to be checking our plate voltages, our cathode voltages. We get to see what our B plus is going to be, because until you put a load on it, it's pretty meaningless, because it definitely pulls down the voltage through all these resistors and the choke and stuff once the B plus gets a load on it. So at this point, I'm not sure if we're going to hit our target voltages or not. I have faith in that PSUD2 software. It hasn't failed me yet. So with all that said, let's get to finishing up the wiring on the output pentode, power this thing up, and see if we've hit our target voltages. Let's get busy. So we got these ground wires hooked up to the common or the neutral of the output transformers, and they're coming over to this tag point. We got this green wire here, comes to this ground point here, over to the center. We got these two electrolytic caps that are grounded here. Power. We're going to pull the power off of the B plus right here with a couple of red wires. We're going to run it from here to here. We're going to run it from here to there. There's going to be a resistor from here to here. This is going to be the RC filtering and also the dropping resistor that goes over to the input triode. We're also going to hook up the positive leads of the output transformer just like that to this same power point on each side. Now some folks will just have one resistor and one capacitor for both channels, and I like separating them into left and right channels for the input tubes, which also isolates them from the output transformers on each channel. So we're going to, and instead of daisy chaining these together, I'm going to run a power wire for each channel over here to this positive. And that's probably overkill, but hey, that's just how I've always done it. And we've created these tag strips to put on this side of these tubes, and we're grounding this and this center terminal and pulling it over to our star ground point. And then this one's done the same way. So this one's going to go right here. Go ahead and screw this guy down. Just like that. And then that one's going to also go to the same ground point. It's going to come across. Like that. And these didn't end up just laying out that neat by their own. I definitely spent a little time bending those up, and I think they turned out really nice. So gonna solder this ground over here. Then we have our two tag strips with the ground points set up. Then the next thing we need to do is we need to come over like this and take these ultralinear leads from the output transformers and hook them up to the screens, and we're going to put a 1.2K resistor at the end of this wire and heat shrink it onto the wire and then solder it onto this pin here. And then we're going to do the same thing over here. Pull this one over and solder it to this pin here with a resistor in the end of that wire. So I'm going to go ahead and do that. I'm going to go ahead and connect up these positive wires to the output transformers, just like that, on both sides. We're going to run these positive leads over here to our B plus. So then we'll have the output transformers powered up. We'll have the screens hooked up. The plate is going to come over and just connect like that to this pin right here. Let me scoot this up a little bit so you can, or let me spin the amp around so you can see that better. We'll be taking the plate lead from the output transformer and connecting it to this pin right here on both channels. Just kind of going up and over like that. And then the last thing we need to do before we power up these tubes and check our cathode current and all that kind of stuff is we need the grid leak resistor, which is going to go from here over to this terminal that I just showed you is connected to the ground. So then we'll have our grid leak resistor, we'll have our plate voltage, then we can hook our cathode resistor, which is going to be a wire from here, and then the resistor is going to go from here to here with a bypass cap, and then we can power this thing up, see what kind of current we have running across the tube, see what our B plus is, and see if we need to make any adjustments on those voltages to make this tube operate. Because the first thing we want to do is power up and get the output portion, which is the pentode, operating with current running through it, get the idle voltage on the cathode, and see if we have calculated up the right resistor values to have this tube operating where it should be happy. So I'm going to get some of this wired up and then get ready to power this tube up. Okay, we've got a lot of the wiring done for the output pentode section of these tubes. And let me kind of go over what we've connected. Like I showed you, we were going to get these ultralinear taps for the output transformer. That's these white with a blue stripe. There's a 1.2K resistor with some heat shrink tubing on the end of each one of these wires. And it's soldered right up against the terminal for the tube socket. Then here are the plate leads from the output transformers, and they're hooked to these pins here, which are the plate pins for the output pentode. This is the grid for the output pentode, and we have our grid leak resistor that goes to this terminal here, which earlier I showed you is connected to ground through this green wire over to the star ground point. These resistors have to be in place when you're testing the tube to give the grid a reference to ground. So here's the cathode of the output pentode, and I just ran some of this PTFE tubing over a piece of bare wire over to this terminal right here to connect this terminal to the cathode. And then we're going to put the cathode resistor between this terminal and here, along with the cathode bypass cap. We'll go across these same two terminals. And for this first test session, I'm not real sure exactly what cathode resistor we're going to end up using. I'm thinking that 750 ohm one is going to be the right one, but it might be a little cold biased, and we might need to go to a lower ohm resistor to get more current running through the tube. So I'm going to be doing more like a breadboard style when I tack the resistor across these two terminals and the capacitor, so we can power this thing up and test the voltages and see if that resistor is the right value. Same with this 120 ohm. I'm not sure where our B plus is going to be. I was initially thinking a 250 ohm, but I went ahead and went with a lower value to raise the B plus up some to hopefully get over 300 volts on the plate, and I'm hoping to see 315, 320, even 330 would be okay, but 320 would be ideal with 35 volts on the cathode. The other thing that we've done is we ran these two red wires from the B plus over here to each terminal on the end of this tag strip. And this is where our B plus is brought over to the tube area. And you can see we have the B plus leads of the output transformers hooked up here. And eventually we're going to be putting a resistor from here to this terminal and from here to this terminal with these two capacitors, and that makes this RC decoupling for the input stage of the amplifier, and it'll drop the B plus down a little bit. I think this was a 2.7K, so it's probably going to drop the voltage quite a bit. And then eventually these get run over to the other terminals that are part of the input triode. So at this point, all I've got left to do is put that 750 ohm resistor the 5-watt one across these two terminals. I'm going to go ahead and put the capacitor across there. Not sure it really makes any difference at this point because there's not going to be any AC in the signal. There's not any signal going through it or anything. So, but I'm going to go ahead and solder them in place anyway. And then we're going to power this thing up and check the voltages and see what kind of adjustments we need to make. Hopefully we'll get lucky, fingers crossed, and this thing will just work like I'm expecting it to. Okay, we're ready now to power this thing up. And this is the kind of exciting part to me because this isn't something that I've actually seen anyone build before, and we took a little liberty with some of these values and the transformers and stuff. So let's see how close my calculations are. I'm hoping to see plate voltage somewhere around 300 to maybe 15 at the most. And then I'd like to see cathode voltage about 35 volts with this 750 ohm resistor. And that would mean, if it was 315 volts, that would mean we have 280 volts across the tube, which should be a good place for this tube to run. But I'm not sure exactly, what's going to happen here. So we're going to set the variac on about 80 volts here and plug this guy in. And before we plug it in, I'm going to go ahead and hook up my ground lead. So we get the ground lead hooked up. We got this on DC volts. And let's plug this thing in. And hit the power button. Now, given this is a solid state power supply, we should see voltage here pretty quickly. We do. There's 273 and 273. But the tube isn't conducting yet. It's going to take a little bit for probably about 60 seconds or so before the tube really starts doing anything. Well, there we go. It's starting to conduct. So let's let the tube warm up. So we know both the tubes are conducting because we're seeing voltage on the cathode. If the tube wasn't conducting, there wouldn't be anything here. So we've kind of stabilized here at 18 volts and 20 volts. And we've got 223 there. 223 there. That's the B plus going to the output transformer. And let's see what we have on the plate. I'm going to be careful here. So we got 220 on the plate. Okay, and that's at about 80 volts on the variac. So let's turn this thing up to about 110. Now we got the B plus 295. The plate's coming up on closer to 290. 287. What do we have here on the... Got 31 on the cathode. We may look out here, guys. I'm going to turn this up to, which should be about 120, and we'll double check that after we get our final voltage readings. We got 318. 318, let's see what we have on the plate. Got 311. 311. 35 volts. and 36 volts. That's right where we wanted to see the voltages. Okay. So we're going to power this thing off, then without touching the variac, let the voltage come down a little bit here. And you can see the voltage. The voltage drops super quick when you have tubes in. We got 1 volt. So we come in here, and I'm going to move this lead over here. So now we're going to power it back up here and give it a second for everything to start drawing current, and then we're going to check the voltage on the input jack. And we got 120 volts. Let's go ahead and turn it up to 121, because that's what my wall voltage is. Okay, so power it back down, give it a minute for the voltage to die off in the amp. Hook our ground lead back up, switch back to DC, power up the amp. And tubes are already warmed up, so it's going to come up the voltage pretty quickly here. And let's see where we're at with 121 volts on the input. We got 320 B plus, 321. The voltage on the plate, this is after the output transformer, it's 313. And then let's see what we have on the cathode. 36 volts. And on this tube we have 37. So this tube on the left channel is conducting a little more current, but that's not unusual. So we got 36 volts and 37 volts. And then we have 313. Basically 313. It's actually 37.7. Okay, let me go do some calculations, and I'll be right back with the numbers on where we're at, and this probably is about where we want this amp to be running. And again, we've just got these resistors and capacitors kind of stuck here more in breadboard fashion. And if this is what we're going to go with, I'll show you how we're going to permanently mount these down here over these cooling slots that I cut in the top of the chassis. Okay, went and ran the numbers. This tube is pulling 48 milliamps across the cathode, and this one's pulling 50. If you remember, this power transformer is rated for 104 milliamps. So that's probably about as hot as we can bias these tubes with this transformer without pinging up against its max rating. And so I think we found the spot. I think these 750 ohm cathode resistors are where we want to be. And again, I was going to show you this. We have 320 volts of B plus. We got 313 on the plate. And then on the screen, we have 312. And that's what I like seeing on an ultralinear amp. I know some people say you can run the ultralinear taps as hot or hotter than the plates, but I like seeing them about 1 volt less than the plate. And this 1.2K resistor seems to be doing that job. And there's 312.5. And then we come in here and check this ultralinear or the screen. 311.5. Screens are 1 volt below the plates. Everything looks awesome. I think this is exactly where we want to be. And so this 120 ohm resistor seemed to be the right size to get the plate where we wanted it to be. And these 750 ohm cathode resistors are definitely the right ones for the tuning that we've done on this amp. So I'm going to get these mounted where they're finally going to be, and then we'll have the Pentode section of these tubes wired up and calibrated, and we can start working on the input tubes, getting the signal wires and the RCA jacks wired up, and we'll soon have an amp that we can start testing and playing music through. Well, as you can see, we hit our target voltages, are really close, and we definitely hit the milliamp ratings for these tubes that we were targeting, hitting 48 and 50 milliamps. It's right at what we've set this transformer up for. Now, again, if this is your first build, or if you're not that concerned about it being on this smaller chassis, probably would be a good idea to make the chassis a little bigger. And that way too, you could maybe go up 1 power step on this power transformer so you weren't pushing so close to the milliamp rating of the power transformer. But I'm not concerned. I think this will work fine. My 6BM8 amp is right up against the power rating of its power transformer, and I think Hammond overrates them a little bit, or gives you a little fudge room. So I'm not concerned about that, but I am excited that we hit exactly where I was hoping to hit with the voltages and everything on this. So another thing I've learned from building SE amps too is I like using a little bit higher impedance primary output transformers than maybe what the tube data sheet says. And I feel good about using 5K ones with these tubes. And one of the reasons for that is, again, I've learned if you push the voltage up higher and run a little less current through the tube, it'll work great with a little higher impedance output transformers, and you end up with less distortion. Now, if you're going to run these at lower voltages and higher current, you would need to lower the impedance of the output transformer to get the same power. So when you look at things like a 300B tube, and everybody says to run like a 3.5K output transformer, well, if you look at the operating points they're running them at, in the 250 volt range and running a lot of current through the tube. And for that, yes, you need a lower primary impedance output transformer to work with the tubes running at that point. But if you raise the voltage up closer to 400 volts and run less current through them, you can run a higher impedance output transformer without any problem and still get good power. It does require more voltage swing from the input tube to drive the tube at that high a voltage, because you've got the bias set higher as well to get the current rating down. And so it takes more voltage swing to get full power. And this amp was originally shown using an unbypassed resistor on the cathode of the driver tube, which does help a little with the distortion, but it also has less voltage swing or less voltage amplification of the driver tube. So we're probably going to end up going with an LED with a small resistor. The unbypassed resistor does give us a little bit of negative feedback on the cathode of the driver tube, which helps. And then we're also going to run shade feedback which also helps. And finally, I wanted to talk about that when you're running one of these pentode tubes in pure pentode mode, you almost have to use global negative feedback to get the amp to perform well and get the distortion levels down. But I've learned when you're running in ultralinear mode, the ultralinear tap helps with the distortion, so it's not quite as smooth as a triode, but it's not as harsh as a pentode. And so you're dealing with less distortion with the ultralinear tap output transformer, and a little bit of shade feedback can get us where we need to be, and I think is a really great sounding amp if you've never listened to one. So that's what we're building. Anyway, hope you're enjoying this build series. I'm having fun building this little amp. Also, thank you to you Patreon folks. It's really helping me afford some of these cooler projects. And for you folks that have given me donations to my website, thank you too. I really appreciate that. So anyway, got the output section done. I think we're kind of over the hill on the difficulty of this. We know this thing's going our way, so we're going to get working on the input tube and get this thing on the audio analyzer suite soon. So until then, have a nice day.